Hi, I'm Sarah Harvey from the LEAP experiment. I'm going to talk to you a little bit about microgravity. So a lot of people think that there's no gravity in space because objects in the space station and in spacecraft appear to be floating around. But they are floating around, but they're floating because they're in free fall around the Earth. So essentially they're falling towards the Earth, but they're falling in a way that they miss the Earth and fall around the Earth. So a good way of thinking about this is by throwing a baseball on Earth. So if you can imagine throwing something, it'll just go into projectile motion and go up and come down some distance away in a parabola. But if you can imagine throwing something with enough initial energy that it went far enough that and fast enough that it went all the way to the horizon and missed the Earth altogether and eventually fell all the way around the Earth and put it into orbit. So anything that's in orbit around the Earth, like the International Space Station or satellites that you get your satellite TV from, or any spacecraft carrying people, is in the same situation. So stuff inside the space station looks like it's floating around because everything in there is in free fall and is falling at the same rate relative to each other towards the Earth. So what the idea with the LEAP experiment is to fly our experimental new plasma thruster in an environment that simulates this microgravity environment in space. So we do this by using NASA's reduced gravity aircraft, or Vomit Comet, to simulate free fall by flying in parabolas so that you get about 25-ish seconds of free fall time at the top and early descent of the parabola. So by running our experiment in that time, in a vacuum chamber, we can simulate the environment of a spacecraft in orbit and in the vacuum of space. So great, thanks for watching.